Hello children, welcome back to the video classes. Last class is discussed about the prime numbers. The definition was that the numbers having only two factors, that is one in itself, are called prime numbers. And also last class we discussed about composite numbers. Composite numbers means the numbers having more than two factors are called composite numbers. So after those two numbers, prime numbers and composite numbers, then we discuss a very important theorem. The theorem was that the fundamental theorem of arithmetic, and according to the theorem, it says that every composite numbers have a unique prime factorization. So that means only these composite numbers only have the prime factorization, and for every composite number the prime factorization is always unique. But for prime number you can't have prime factorization. So you have to remember that only composite numbers are showing the prime factorization, and those should be always unique for every number. And that is called the fundamental theorem of arithmetic. Now today we will apply this theorem to solve few problems of exercise 1.2. So today's question number is 5. The question number 5 says that check whether 6 to the power n can end with the digit 0 for any natural number. So this is 6 to the power n, power is n, which is natural number. So whatever natural number you put, and if you simplify, so will you get 0 at the end or not, that you have to check. So solution you write here. Right, if 6 to the power n for any n is to end with the digit 0, then the prime factorization of 6 to the power n must contain the primes 2 and 5. So therefore now you check the prime factorization of 6 to the power n, right? But 6 to the power n equal to 2 into 3 whole to the power n, where the prime 5 is missing. Now will you get any prime factorization of 6 other than 2 into 3 where the primes 2 and 5 are available? No, because we know that according to fundamental theorem of arithmetic, the prime factorization of 6, that is 2 into 3, which is unique. So we can't get any prime factorization of 6 other than 2 into 3, because this 2 into 3 is unique for the composite number 6. So there is no chance of getting the prime factor 5 here. So we can't get 0 at the end when we solve this 6 to the power n for any natural power. So after writing this, after getting the prime factorization of 6 to the power n, here it is confirmed that the prime factor the prime 5 is missing. Then you write also according to the fundamental theorem of arithmetic, this prime factorization for 6 to the power n is unique. So therefore we can't get the prime 5 in the prime factorization of 6 to the power n. So 6 to the power n cannot end with the digit 0 for any natural number n. So this is the solution. Just we have used the concept of the fundamental theorem of arithmetic. So hope you have understood. Now after question number 5, we'll solve question number 6, that is also based on the fundamental theorem of arithmetic. So note down question number 6. Question number 6 says that explain why this number and this number are composite. So these two numbers are composite. Now you have to explain, you have to give reason. Solution. First you write 7 into 11 into 13 plus 13. Now in this expression there is a plus sign. So this plus sign will separate the whole expression into two parts. So this is one part, that is another part. So from both the parts you can take 13 common. Take 13 common, then inside the bracket it will be 7 into 11 plus 1. So 13 into 77 plus 1 equal to 13 into 78 equal to 13 into, now this 78 you can find the prime factors of 78. The prime factor of 78 will be 39, 3, 13. So it will be 2 into 3 into 13. So finally we have got this prime factorization. Because each and every factor is a prime number and each prime factors are connected with your multiplication symbol, so this is a prime factorization. And we know that prime factorization always represents your composite number, because composite numbers only give prime factorization. So as this prime factorization I am getting from these numbers, this prime factors I am getting from these numbers only, so therefore This means that this number represents a prime factorization, therefore this number is a composite number, right? It is a prime factorization, right? Therefore 7 into 11 into 13 plus 13 is a composite number by fundamental theorem of arithmetic. So use this method. I am leaving the second part to you. Here also see this expression is containing one plus sign, so this plus sign will separate the whole expression into two parts. In both the parts you take 5 common and follow this procedure, and finally you try to get one prime factorization, and that prime factorization will prove that the given expression is a composite number. So second one I am leaving to you. And question number 7, after 6, question number 7 also it is homework, and which is simply find the LCM of the two numbers, you will get your answer. So I hope this second part of question number 6 and question number 7 you will do. Then after this our next exercise will be your based on irrational numbers. So in class 9 you got the irrational numbers. That means the numbers which are containing the root over sign, square root, the numbers containing square root are the examples of irrational numbers. For example, you see 2 root 2, root 3, then root 5, root 6, etc. This type of numbers are treated as irrational numbers. But here you see after root 3 it should come root 4, but root 4 is not an irrational number, because root 4 I can get the perfect square root, that is 2, and it is a rational number. So root 4 is not irrational. Like that, root 9 is not irrational, root 16 not irrational. They are always rational numbers because you can find their perfect square root. So this type of numbers you studied in class 9, class 10 you have to prove this type of numbers as irrational numbers. So I'll prove root 2, and whatever procedure I follow, if it is in exam coming root 3 or if it comes root 5 like that in exam, you follow the same procedure. I'll show this root 2. How to prove this root 2 is an irrational number. Now before proving irrational numbers, some basic things you must know, like your co-prime numbers. What do you mean by co-prime numbers? Two numbers are said to be co-prime numbers if they have only one as common factor. So for example, pair of numbers 2 and 3, these two are co-prime numbers. Then 3, 4 co-prime numbers because they have only one as common factor. Then your 8 and 9 co-prime numbers. Then 4, 9 co-prime numbers, etc. Now see here, this is a rational number. In this rational number, numerator and denominator, they are not co-prime numbers. But we can change this rational number and we can find both numerator and denominators as co-prime numbers. How? Just by cancellation. You cancel by 2, 2, 3 is 6, 2, 4 is 8. Now this is coming a 3 by 4. So this 3 by 4 is a rational number, but you see 3 by 4 and this 6 by 8 both are equivalent fractions. But here this is called simplest form, 3 by 4. As this is simplest form, then in that case you can see that numerator and denominator both are co-prime numbers. So here 3, 4 are co-prime numbers. So in simplest form, this is in simplest form only you can get the numerators and denominators as co-prime numbers. So see, from now you should remember that every rational number can be converted into the simplest form, and in that case the fraction will have numerator and denominators and both will be your co-prime numbers. So this co-prime numbers concept you have to use to prove that root 2 or root 3 or root 5 as irrational numbers. So now let's start with root 2. So question is that prove that root 2 is an irrational number. Start the proof. But we don't have any direct proof for proving irrational number. So what we'll do, we'll apply the contradiction method. Contradiction method means what you are asked to prove, you have to assume the opposite one. As root 2 you are going to prove irrational, so you have to assume that root 2 is a rational number. So write let root 2 be a rational number. And see, every rational number can be written in the form of a by b. Therefore root 2 can be written in the form of a by b, where a and b are, now see this rational number a by b, assume that this rational number is in simplest form, and if this a by b rational number is in simplest form, then both a and b are said to be co-prime integers or co-prime numbers. So where a and b are where a and b are co-prime integers and b is not equal to 0. Now if a and b are co-prime integers, so therefore a and b must have only one as common factor. Therefore a and b must have only one as common factor, because a and b are here co-prime integers. So right now root 2 equal to a by b, then square both sides. Right here squaring both sides. This implies 2 equal to a square by b square. So you write a square equal to 2b square. So after getting this, from here you can write that therefore a square is divisible by 2, because you can take in that form that you can take this as dividend, that is equal to divisor into quotient. You can take here no remainder, only dividend you can take this, and divisor you take 2, quotient you take this b square. So you can take this in the form of dividend equal to divisor into quotient. So if you see it is in the form of dividend equal to divisor into quotient, then this means that a square is divided by, or a square is divisible by 2. So that's why I have written that a square is divisible by 2. So this implies if a square is divisible by 2, then a also divisible by 2. So if a is divisible by 2, or if we divide a by 2, then there will be one quotient. Therefore a is the dividend, divisor is 2, then quotient you can take q. So write for some integer q. Now what you do, this a equal to twice q you put here, mark this equation number 1. Therefore putting a equal to twice q in 1 we get, so what will get here, 4q square equal to 2b square. So both sides 2 to cancel, 2q square equal to b square. So this implies b square equal to twice q square. So both sides 2 to cancel. After putting this is equal to twice q in equation 1 here. So left hand side 4q square equal to 2b square, both sides 2 to cancel, so 2q square equal to b square. Now b square I have written left hand side b square equal to 2q square. So again you take this as dividend equal to divisor into quotient. Right, therefore b square is divisible by 2. So if b square divisible by 2, then this implies that b is divisible by 2. So mark this as equation number 3. This one, a is divisible by 2, and this b is divisible by 2. Mark this. This is 2 and this is 3. Now from result 2 and 3, it is clear that both a and b are divisible by 2. So 2 will be a common factor for both a and b. So it is clear from result 2 and 3 that a and b are having one common factor, that is 2. Therefore from 2 and 3, it is clear that a and b have one common factor, that is 2. But in the beginning we have assumed that a and b are both co-prime integers, therefore there must have only one as common factor. And here I am getting that a and b are having one more common factor, that is 2. So in the last I am getting one impossible result, as a and b are co-prime integers, so they cannot have any common factor other than 1. But here I am getting other than 1, I am getting the number 2 also common for both a and b. So this is not possible for two co-prime numbers. So at the end I am getting one impossible result. So if I get any impossible result at the end, then this will show that something wrong is done in the beginning part. So whatever we have assumed in the beginning, that root 2 be a rational number, for that assumption only I am getting one impossible result at the end. So that's why I can say that our beginning assumption, that is root 2 is a rational number, is also a wrong assumption, for which I am getting one wrong result or impossible result in the end of the sum. So therefore your conclusion will be, so you have to write that, but this is not possible as a and b both are co-prime integers. Okay, so impossible result is coming in front of you. So what will I then after that? This contradiction arises for our wrong assumption that root 2 is rational. So therefore root 2 is an irrational number. So finally you have to prove that root 2 is an irrational number. This is called proof by using contradictory method or contradiction method. Okay, so I have shown you root 2. If it is coming root 3 or root 5 or root 7 like that, or root 11, then always follow this process to prove the numbers as irrational numbers. The next question I will give you, which will be a mixture of rational and irrational. The question is, prove that root h is irrational. Solution. In solution you write, we have root 8 equal to 2 root 2. So here it is clear that this term is a mixture of one rational number and one irrational numbers, because root 2 already it is proved that root 2 is irrational number. So if it is a mixture of rational and irrational, then our method will be more easier. So see how we will solve it. Again here also you have to apply the contradictory method. So write let root 8 be a rational number. Therefore root 8 equal to 2 root 2 equal to a by b, where A and B are integers. Here co-prime word no need to mention, because if the question contains a mixture of rational and irrational, then no need to apply the method of co-prime numbers. Without applying co-prime numbers, I am doing this as in the form of A by B. So therefore I'll apply this only to get the answer. So from here, therefore root 2 equal to A by twice B. So now consider on the right hand side, both A and B are both integers. For A and B are integers. 2 is multiplied with B, so twice B also an integer. So this is an integer. So this will also be integer, because this is, there is equal sign. But this contradicts that already we have proved root 2 as irrational number. So we will get one wrong result here. Now see how to get it. Here A and B are integers. This implies A and twice B are also integers. So if A and twice B integer, therefore it will be a rational number. So therefore A by twice B is a rational number. So if A by twice B is a rational number, now A by twice B is equal to root 2. So replace this by root 2. Then I had is a rational number. But is it possible? No, because already we have proved that root 2 is an irrational number. But here it is coming root 2 is a rational number. So one impossible result I am getting, and this impossible result is coming from our beginning assumption. In the beginning we assume that root 8 is a rational number. So that assumption is wrong. So here at but we know that root 2 is irrational. We know that root 2 is irrational, but here it is coming root 2 is a rational number. So one contradiction is coming, impossible result. So what you write? This contradicts the fact that root 2 is so this contradicts the fact that root 2 is root 2 will not come here, because original number is root 8. So you write here root 8. So this contradicts the fact that root 2 is rational, because our assumption in the beginning is root 2 be a rational number. For this assumption, root 2 is be a rational number. For that assumption, we are getting one impossible result at the end of the solution. So that's why I have written that this contradicts the fact that root 8 is rational. So whatever we assume root 2 as rational in the beginning, that is wrong. This contradicts the fact that it is wrong. This is possible. It is not possible. So what will write finally? So write this contradiction arises for our this contradiction arises for our wrong assumption. So therefore our final answer will be, therefore root 8 is an irrational number. So root 8 is finished. One more question you take. Question is prove that 3 plus root 2 is irrational. Here also see it is a combination of rational part and irrational part, and both rational and irrationals are combined with plus sign. So here also you can prove it as irrational numbers, but method will be contradictory method. First you have to assume that this is a rational number. Right, let 3 plus root 2 be rational. So therefore 3 plus root 2 can be written in the form of a by b, where a and b are integers and denominator b is not equal 0. Then root 2 equal to a by b minus 3. This implies root 2 equal to a minus 3 by b. So here a and b are integers, a b integers, so a minus 3 also integer, b also integer, so this is a rational number. Here a and b are integers, so this implies a minus 3 and b are integers. If numerator denominator are integer, therefore a minus 3 by b is a rational number because the numerator and denominator both are integers. So this equal to what? This equal to root 2. Root 2 is a rational number. But is it true? No, we know that the root 2 is an irrational number, but here it is coming rational number. So here's one impossible statement I am getting, right, which is not true, as root 2 is an irrational number. Then you write this contradiction, arises for our wrong assumption that wrong assumption that 3 plus root 2 is rational. Therefore 3 plus root 2 is irrational. So see this carefully and go through the video. Try to understand each and every sentence, and if possible, if required, you can repeat the video, because you see in this type of proof we don't have any step-by-step procedure. Simply you see it is full of some type of writings only, like written work. So try to understand the step by each line. You have to try to understand, and you without looking you practice, because practice is very important. Otherwise you will, if you understand also, so after 2 or 3 you will definitely forget, and you will not be able to write the answer. So for this type of sums, maximum practice is required, and based on this type of numbers I'll give some extra questions. You solve it and I submit in my WhatsApp number. Okay then, thank you very much and bye bye.